Good morning. Welcome back to Open Med School. I am Dr. Andrews, Professor of Medicine and Principal P.K. Das Institute of Medical Sciences. In the last session on JVP, we have discussed the method of examination and why internal jugular veins are preferred over external jugular vein. The patient should be positioned at 45 degrees slanting, and you can apply light tangentially. And if JVP is not visible properly, you can use a abdominal compression of the abdomen, that is abdominal jugular reflex, can also be utilized. Today I will be discussing the various waveforms, how they are formed, and what are the underlying events occurring in the cardiac cycle. Let us start. The waveforms in the jugular venous pulsations are due to the pressure changes that is occurring in the right atrium. So let us see what is happening in the right atrium. The right atrium contracts once the P wave is generated, or you can say the sinus node produces impulse. It produces depolarization of the atria, and that forms the P wave. And this will lead on to contraction of the atria. So you can see the atrium contracts, otherwise called the atrial systole. This increases the pressure in the right atrium and is visible in the JVP as the A wave. So A wave is due to atrial contraction. Atrial contraction lasts for around 0.1 second. Immediately the atria goes into relaxation, and this produces a sharp descent, that is the X descent. That is the pressure in the right atrium comes down, this leads on to the X descent. Once atrial contraction is over, the ventricle starts contracting. When the ventricle contracts, the pressure inside the ventricle increases. That will produce rise in pressure, leading on to closure of the atrioventricular valve, and that produces the first heart sound. So now we know the mechanism of the first heart sound. First heart sound is produced due to closure of the atrioventricular valve, and here comes the S1. So A wave is prior to the first heart sound. So it is a pre-systolic event or occurring during the diastole of ventricle. And we are seeing the X descent. And during this time, the ventricle is contracting. That will produce bulging of the tricuspid valve into the atria, and that produces a mild rise in pressure, that is the C wave. So X descent is interrupted with the C wave. Remember, C for cusp. Cusp is bulging into the atria. Again, during the ventricular contraction, the ventricle is squeezing the blood, and the size of the ventricle comes down, and in the pericardium there is space for the atria to dilate little more, and this will lead on to continuous drop in pressure in the atria, and that will be represented as the X1, X dash descent. So X dash descent is occurring during ventricular systole. And remember, now the atria is receiving blood from superior vena cava and also inferior vena cava. So the pressure inside the atria starts rising. So now comes the rise in pressure, and this is the the V wave. So V wave, you remember, V stands for venous. So it is due to the venous filling occurring during ventricular systole. So this time is ventricular systole. Now ventricle has ejected blood into the pulmonary artery and also from the left ventricle to the aorta. Now contraction is coming down and now time for ventricle to relax. So this will lead on to a sudden reduction in the pressure inside the ventricles. So the blood from the aorta and pulmonary artery will try to enter the heart. So I draw the picture. So you can see this is the heart. These are the AV valves, and here comes the aorta, and here comes the pulmonary artery. So the blood will try to enter back. So this will lead the semilunar valve now closes. Close to the semilunar valve we hear as the second heart sound. So second heart sound or S2 is due to the closure of the semilunar valve occurring when the ventricle pressure is lesser than the pressure inside the aorta and the pulmonary artery, and this leads on the second heart sound. So this produces the second sound. So what's mechanism of second sound? Second heart sound is due to the closure of the aortic and pulmonic valves. So the time interval between systole is the beginning of the or the start of S1 to the S2. So this is the systole. And now we can see that the V wave is occurring during ventricular systole. As I have told, this point you should remember, that is V wave is occurring during ventricular systole, the continuous filling of atrium that is happening. Hope this point is clear. Now it is the diastole. So during diastole what happens? The ventricular pressure is coming down. The pressure becomes lesser than the pressure in the RA and LA. So what will happen? The AV valves, atrioventricular valve opens. This will lead on to drop in the pressure inside the atria. The atrial pressure comes down because AV valves are opening. 70% of the filling of the ventricles are occurring during this time. So there is a sudden drop in the pressure, and that is represented as the Y descent. So this is the Y descent. So we have got two descents, X descent and Y descent, and three positive waves. That is the A wave due to atrial contraction, C due to the bulging of tricuspid valve, and B due to continuous filling of the atria occurring during ventricular systole. Now it is the diastole. So heart is filling. At the end of diastole, what happens? The atria now is full. So atria will start contracting. So that leads on to the, so here at the end, this the end of diastole of ventricle, the atria contracts and the cycle repeats. A wave and the, so these are the events that is occurring in cardiac cycle. So just you should remember, should be able to correlate this with the ECG. So as I have told you, the atrial depolarization is the P wave. So atrial depolarization leads on to the P wave, and this leads on to atrial contraction that produces the, in the JVP you get the A wave, and the sound that you get will be the S4. So all these are correlated. Then comes the depolarization of the ventricle. At the peak of R wave starts the contraction of the ventricle is happening. You get the C wave, and the systole starts. Bulging of the tricuspid valve is occurring. Then the pressure is coming down. You can see in the ECG there is the T wave. T wave is the ventricular depolarization, and at the end of the T wave starts the ventricular diastole. So if you draw the ECG, this is the ECG findings. So top of R wave, to the end of T, this becomes systole, and the diastole is from this point to beginning of the pubis. So this is how you correlate with the ECG. If you draw the ECG, the JVP, the A wave is atrial dipole contraction, C wave is bulging, pressure comes down, X descent, continuous filling, the V wave, and the AV valve opens, suddenly the pressure drops. That is the Y descent. Again the cycle repeats. So this is what we should know about the JVP. So in this session I have discussed with you what are the waves in the JVP. Even though there are three positive waves, we can see only the A wave and V wave in a normal person. That only you make the patient slanting, because normally the pressure is not more than 3 to 4 centimeters from the sternal angle, so you cannot say in the sitting position, you cannot sit. And I have discussed the generation and how the cardiac events, including the heart sounds, electrocardiac events, and the pressure changes are occurring. In the next session, I will be discussing various abnormalities of jugular venous pressure and pulsations. Stay tuned for further videos. Thank you.